Today we're looking at Rhino Inside and how to be able to take adaptive components and break them up into 3 different types based off of an image driver. Now, if we look at the screen here really quickly, this is kind of what we're looking at in Revit. We've got native Revit adaptive component geometry. It's all driven by this Photoshop file. Now, this is just something I sketched up here really quickly. And it's going to be testing how black or white it is to set the type. And then we're going to be able to show you how to do this custom shape and rationalize this surface all directly from Rhino over to Revit and into Revit native geometry. So that's where we're going today. So if you're excited to get into this workflow, go ahead and open up Revit. And you can open up something completely from scratch. And basically we just need to go ahead and fire up Rhino and Rhino Inside, and then we'll go ahead and get into the workflow. Okay, this might take a little bit longer, but make sure you stick around to the end because there's a lot of tips in here covering subcategories, making dedicated subcategories for each adaptive component. We'll do a separate video to actually model the adaptive component, which I'll link to here right now if you haven't already got that in place, as well as I'll make sure it's available at the end, but I'll briefly touch on it if you have experience with adaptive components. Super simple, and then we'll focus just purely on the configuration of Rhino Inside. So let's go ahead and dive in. So I've gone ahead and launched a fresh Grasshopper, and again, if you haven't done that, just go to the Rationalize tab after launching Rhino Inside from the add-ins, and then I've launched Grasshopper right here. You're also going to need to launch Rhino, and I've done that as well. And then if you don't see those right away, just make sure you tab over to them. So what I've done is I've just modeled 3 different curves here that I'm planning to loft together, okay? And what I can do is just go to File in the Params tab and just go to a curve input, and then I'm going to right click and say set multiple curves, and I'm just going to pick those 3 curves that I've modeled. Okay, next I'm going to go ahead and just type in loft, and I'm going to take those curves and loft them together. Now if they're in the wrong order, just make sure you right click and do manage curve collection, and make sure you've got those in the correct order. That's going to be the order that you modeled them in Rhino, okay? And that should correct your surface, okay? So just work on that. The next thing I want to do is, there's a couple ways to visualize this. So if I wanted to actually get some geometry into Revit really quickly, let me go ahead and just hide all of this for right now. So I'm just gonna temporarily hide it. Using the glasses right here. Okay. And toggle back to Rhino. So if you wanted to get some geometry out right away, you can go to the Revit tab that's installed with Rhino Inside and go to Direct Shape and just say Add BREP Direct Shape. And you could pipe that in and you'd get a surface out right away that has a generic model applied and it's set to the new construction. But we want to go further than that. Okay, we want to set the adaptive components. Okay. One more way you could do this too, that I was testing out, was actually doing some ISO curves. So if you haven't installed Pufferfish, I highly recommend it. I use this all the time. I'm gonna go ahead and just go to Pufferfish, go to Curve, and then go over here to Parameter Surface ISO Curve. And I'm gonna go ahead and just feed my loft into surface. Now this is asking for some parameters, and that's just a percentage from 0 to 1. So to get some divisions in there, I'm just gonna type in range. And by default, you can see it's 0 to 1 right there. And so I'm gonna feed that in. And then you can see I'm getting a preview down here in Rhino. And then if I wanted to increase the amount of divisions I'm getting, I could just go a slider, 1, less than 10, less than 100, and put that into steps. And then I can just simply crank that up and start to get more divisions down here. right? And this is sometimes I use this just as a really quick way to visualize what I'm about to get. So if I wanted to just copy that, what I can do is just take this, alt drag a copy, and then just do a boolean, and I'm gonna say this direction is true, which is the first direction, and I'm gonna go ahead and just do a not gate, and then just feed that into the direction. So one of these is getting the vertical and one is getting the horizontal. Okay, and then I can just change those number of divisions as needed over here, you can see. And if I want to get that out, again, I could just simply entwine those or merge those. And then that's going to give each of those a branch. And the way that Revit is rendering all this geometry, it's not going to matter. So you just have to know that it's serializing some information through the script. So if you stop using the script, it all becomes an individual element unless you do some additional steps to group it before you do so. But right now, you could basically just go up to Revit and again, direct shape, and just do an add curve direct shape. And now that's going to go from Rhino over to Revit. Okay, but we're going to take this a step further. Okay, we're actually going to start to rationalize this into different typologies within. Okay, so let's keep going. So to do that, I want to take my loft once again. I'm going to go ahead and just disable this, and then I'm going to go ahead and just do a couple things. So one of the first steps you want to do is I've already prepared a 4-point adaptive component. Okay, and I'll just kind of briefly walk through this. Again, here's a link. I'll link to it up here. Just check out the little card to see the video on how I prepared this. It's a pretty easy setup, but I've just got a 4-point adaptive component, and then I've got this interior set of reference lines to create this offset surface, and then within those inner layer of reference lines, that's where I've applied my surface. I've hooked up a material to it right here as a type parameter, and then I've also given it a subcategory of adaptive surface. That allows me to target it once I load it into my project. And then what I've done up here is I've just specified 3 different types. So you can see the first type has the offset is 2 and 4 inches, and that's referring to these points here. So the first one, I've set the point on this reference line. I've set it to segment length, and then it's measuring relative to the end on one side, and on the other side, it's relative to the beginning with the same segment length. And then I've hooked that up to offset 1. So this direction is offset 1, and then this direction is offset 2. So again, relative to the beginning and end, and we're good to go. So I'm going to go ahead, and I've already loaded that into my project. So once you load it into your project, you can see I've got some overlapping geometry here. But here's my working view. Okay, so what I'm going to do now is I'm going to go back to Grasshopper, and just for simplicity, there's a bunch of different types of tools you could use. You could use paneling tools or a lunchbox. There's a bunch of different ones that can rationalize surfaces. I also recommend this M+. You can do some really awesome tiling and rationalization and stuff like that. So basically you can jump right into the rationalized surface, and then we're gonna extract the points within that surface to get the equivalent 4 points together for the adaptive component. Now you could, in the kind of vanilla out of the box Grasshopper components, you can go to the surface tab up here, go over to utilities and divided surface. The downside of this one is that you don't get the points grouping into a branch. You don't know which branch they're all on. So if I just feed these points out, you can see It's basically just organizing them by U and V, so an entire row of points. It's not knowing relative points to each cell. So use paneling tools, lunch blocks, or M+. So I'm gonna go ahead and use lunch box. And then I'm gonna go ahead and just go over to panels here and just go down to this, I'm gonna do the staggered quad panels. And again, feel free to explore this. I'm gonna go ahead and feed my surface in. And then I'm gonna change my divisions. And real quick, before we do too much farther, I'm just gonna just not use the lines we made. We're doing a whole different rationalization process right now. So I've got my staggered quad panels, which again is right there in Lunchbox. And I'm gonna go ahead and feed a couple divisions in. So I can just reuse these sliders right here by alt-dragging copy. And I'll just feed one into the U and then the other into the V. Okay, and I'm just gonna hide this just so I can kind of visualize what's going on. Okay, so there is my surface that's been rationalized. And again, I can just start to play with this, make it as complex or simple as I want. Okay. Next part I want to do is actually I'll keep working through this here. One of the things is if I take a look at what I'm getting out here, it's actually a flat list. I can tell by those solid lines there. I need each of these surfaces on its own branch so I can work with it independently. I'm gonna go ahead and graft this tree, putting each one of those surfaces on its own branch. And then the next step I'm going to do is get my image. So I've gone ahead and again prepared this ahead of time, just simply using a brush with some adjusted opacity set to black and white, and then I've just drawn on that layer. Feel free to do your own exploration. I just created a new layer, filled it with white, created a new layer up here, hit brush with black active, and then just kind of started to explore, and then just kind of painted something in. You can do things that are much more performance driven, data driven, but basically we're just going to drive this from an image. Okay. So what I want to do now is just pull up an image sampler. So just type in image, and then I'm going to double click in and navigate to that file. And I've got it saved right back here. Okay, so now that that is loaded, I can take a look at what I'm getting out. And right now it's nothing, but basically imagine this image sampler as your surface, okay? And each one of your panels is kind of like a pixel. So I need to go ahead and map points from my surface onto my image and then use that to drive it. So to do that, I want to go ahead and just get a center point for each of my panels. So I can do that by just going to surface and area. That's going to go ahead and return the centroid. And so now if you see there's a middle point for each panel. And then I'm just going to type CP for closest point and navigate up to the surface closest point. And we're going to want it to be not our panel surfaces, but our original base surface. Okay. And we're going to feed that into surface and then our centroid into point. And the main thing we wanted are these UVs right here. Now, before we go too much farther, if I was to just put this directly in, it would give me some information. But I know if I double click inside, this domain is actually going from 0 to 1 and 0 to 1. So that's that percentage. And if I feed these UV points in as is, that's actually still relative to the length of my surface. So to normalize that, I can just go ahead and type in surface to get a component here, right click on it and say reparameterize. That'll make it that 0 to 1 in both U and V directions. And then just holding Control and Shift, I can just take this input and adjust it to there and then feed that surface in. And I might as well just put it back here as well. So now I've got that reparameterized. Okay. So now I'm gonna go ahead and just hide a few things, and now that should go ahead and propagate as intended. Now we have some information coming out, but it's actually giving me RGB values, and I want a percentage, a number percentage relative to how black or white it is. So to get that information, go ahead and double click in the image sampler and change it to the brightness. And again, these are all different filters, so you can get just the blues or just the greens, but we want this one on the right. Now that gives me a percentage. If I can just scrub here, I can start to see some different values. All right. So now, eventually, we're going to be landing at the Revit adaptive component, Grasshopper component. That's a mouthful. So to find that, we can actually do add or do build, and we can say add component adaptive. Okay, and this is going to be asking for points and type. So what we're setting up right now is we're going to get our points directly from our panels, and basically to get those points, we can just do deconstruct brep. So if I just go to surface and deconstruct brep right there, I can feed each of these surfaces in. Now I want to do it from the branch so they stay together. And again, this is going to give me my faces, edges, and vertices. Okay, so now each branch is going to have 4 points that are relative to that panel. Okay. Eventually, this is going to go right into points up here, but now we just need to figure out how to set our type. All right. So for simplicity, if you wanted to just add a single type in and not worry about these 3 different types business, the way to do that is just go to the Revit tab, go to Input, go to Model Categories Picker, and you need to know which category your adaptive component is in. Okay, so you're not going to find a dedicated adaptive component category. So if you go back to your adaptive component family, you can find it by either just seeing it right here, generic models, or I can go up to this little folder and it says it right there, generic models. Okay, so it might be in a different category, but typically it starts in generic models. So just be mindful of that. Okay, I'm gonna go back to my model here and Alt Tab back to my Grasshopper script. Okay, so I've got my input, again, that's right here. Oops, that is right here, Model Categories Picker. And then I can just go to Input and go down to Element Type Picker. And if I just feed that in, it's gonna give me an option within all the types in generic models. Okay, and I can see because I've named my family adaptive 4-point, that's the name of the family. I know that that's right there. Here's my 3 different types. Now, if you just loaded your adaptive component into your project, to make sure it's in that list, just right click and say recompute. Okay. All right, so if you just want to type 1, you could literally just come in here and feed this in and you're good to go. Okay, and it's going to take a second because it's a really big surface here. Let me just so it's going to take a second, but just keep an eye on the output, and it's going to generate it over here. I'm going to go ahead and cut to after this loads because it does take a second, so be mindful before you run the adaptive components. Make sure you're double checking your data before you put it into this component. It's super critical. You could crash Revit, you could crash Rhino. Just double check your your trees branches are lined up. You've got the right amount of points to match up with the adaptive points, right? So if I had a 4-point adaptive component, I've got 4 points in each branch, and those all line up as intended. And then go ahead and run it. So I'm gonna go ahead and cut to the end, and we'll keep going from there. So we have applied our basic component, and this is parametric. If I wanted to edit type 1, I could do so, but I'm not gonna do that right now. All right, so now we want to get types driven by our image. So let's go ahead and get back into that. So I know this just took like 3 minutes to reload, but I'm gonna go ahead and undo that script run right there. Okay, and Alt Tab back to my script. There we go. And before I forget, I'm gonna go ahead and save that. All right, so before I forget, do middle mouse and disable while we get this sorted out. Okay, but like I mentioned, just matching up your points to the type. So we basically just batch apply this entire type to every branch, which represents each panel. Okay, but now we want to basically get a dedicated type per branch, and that's where this comes in. All right, so what do we do now? Well, we want to work towards this domain includes to help filter what we're including in each type. Okay, so let's just do that. We want to go ahead and build a domain. Okay, and so I'm going to do construct domain. By default, it goes from 0 to 1, which is just what we need. And yeah, and then we can just go up to domain and divide domain. And I know that I just have 3 different types. You could make this as many types as you want. I have 3. So I'm going to do quotes and 3, and then put that into the count. All right. Now, if I look at this, you can see I have 0 to 0.333, and I've got 3 different domains here. So I'm going to go ahead and put those domains in here, and then I'm going to feed all these percentages into the value. Okay. So now if I go to includes, there's going to be a whole bunch of true falses. So I just want the true values. Okay. So instead of doing like a pattern filter, stuff like that, I'm just going to do member index. Okay, right there. There it is. Okay, so we are going to look for a Boolean, and we're looking for true, and that's the member, and the set we're testing is this whole set right here. And the result is the index that is true. So all we need to do now is build a little list to grab which type is associated with it. So I'm going to go ahead and build that list, and just alt dragging a copy. I'm going to set another one to type 2, and alt dragging a copy and do type 3, and then just merging those together into their own list. This is my little set of families, and I can just take a look at that. And there's my list of 3, okay? That's the code speak for those types, cool. So now all I need to do to get those types out is just to do an item, okay? And there's my index, and that's gonna pull that, index number 1 from this list up here. So I'm gonna go ahead and feed that list in. Go ahead and feed those indexes in there. And now it's gonna be picking out the correct type based on the branch. The final step is, I explained this earlier, so I'm not gonna re-explain it. The final step is just to make sure our branches are lining up. So just to verify that, I could do viewer and just look at this really quickly. Alt drag or copy, and whoops, I need it for my points here. So you can see right there, I've got 1,681 branches, 1,681 branches, and it looks like I have the same branch structure in both. And I can just verify that by just kind of scrubbing down here. If I was concerned about them not matching, I could just do a match tree, and I could say use these points as a guide, and then this tree to update, and I'll just do a little relay by double clicking on it. And so now the points go in here, and then the updated types assignments will go in here. And that is pretty much it. So all we need to do now is just re-enable this, and everything should propagate up here. So let's do that. Middle mouse, enable. Go make yourself a coffee. Maybe watch an entire basketball game or whatever your favorite sport is, and come back when you're a year older. All right, so we are back in business, and now we can take a look at the results of what we got going here. So you can see I've got type 3 up here, I've got type 2 in the middle here, and type 1. And again, these look smaller because of how the divisions were working in Rhino, but type 3 is actually a bigger inset, I guess. So that's why it looks a little bit weird. Now, if you wanted to really work with changing this to make them more consistent, that's a whole nother level of rationalization that we're not going to get into in this one. But you'd have to really understand how your surface is coming together. So let me just hide some of this and get back to this one here. So you can see you'd have to really understand how this stuff is compressing. And I'm pretty sure it's just, these are all custom. So if you wanted to make these prefabricated sizes, that's a whole nother discussion for another day. But in terms of the workflow, if you were able to go through a rationalization process, you can use this as a sorting mechanism to filter out and group and basically create 3 different branches with 3 different types and set those 3 different types here. And again, this is based off of an image driver, but you could do this based off of a data set, based off of performance, based off of a whole bunch of different options. So feel free to really consider what is driving and grouping things off for you. You know, it could be deflection amounts, could be all kinds of things. Okay, so that's basically the workflow. And the results are looking pretty darn good. I'm not going to recalculate this, but what are you most looking forward to? How are you using adaptive components in your day-to-day workflow? Let me know in the comments below what you want to learn next. We're going to be exploring Rhino Inside over the next 4 to 6 weeks, and really excited to be doing a whole bunch of different studies that can make be making Rhino and Revit come together. Hey everyone, thanks so much for tuning into this video where we explored how to create 3 different types in Revit driven by Grasshopper and some Grasshopper logic. I'm really excited to see what you come up with. Again, if you want to learn how to create the simple adaptive component, go ahead and check out the video linked up in the description here. Otherwise, again, we'll be exploring this over the next coming weeks, and leave a comment below what you learned, what you're excited to learn next, and I look forward to seeing you next time. All right, thanks so much, and stay curious, my friend.